Good afternoon, everybody. I'm gonna go old school. Decided not to bring my laptop. Figured I'd bring my notes. Seems like I'm in good company, so thanks for leading the way. So, 30 years ago, I'm sitting at a stoplight, and I go to put my truck in gear. By the way, this is exactly what the truck was. I go to put it in gear, and nothing happens. Unfortunately, or fortunately at the time, I knew exactly what was going on because it had happened before. I had a linkage that would slip out of place. So, in the middle of traffic, at a stoplight, I get out of the car or the truck, crawl up under the truck in the street, jiggle the linkage back in place, get back in the truck, shift it into gear, and drive off. I'm guessing that not many of you have done that, and certainly aren't doing it today with your vehicles today. So the thing is, vehicles have changed a lot, and complexity has changed a lot. I want to give you a little bit of information about my background. I'm not an auto engineer. I'm not a quantum physicist. I'm certainly not the smartest person in this room. But I've been around for a long time. I've watched computers go from the old IBM beige XT desktops using productivity software. I've worked with virtual machines. I've built Novell and NT servers. I've built cloud environments for customers. Right now I'm working with AI and creating AI applications with people. Looking forward to the future and what's coming next. So one pattern that I've seen through all of that is that we tend to create new things that do cool things and more things. They make it easier for the end user, but those new things create more complexity. And that has gotten more and more complex over time. I don't know if you guys are familiar with the old TV show Once Upon a Time and Rumpelstiltskin. One of his famous sayings was, "All magic comes with a price." So sometimes I think the stuff that years ago would have seemed like magic, the complexity that we're dealing with today, it does come with a price. It comes with the complexity and dealing with that and managing that complexity. Think about vehicles and the progression of vehicles. They're totally different than they used to be. And that's good. The original, old cars that were created were the thing to have at the time. My personal favorite, place very dear in my heart, the old muscle cars. Everybody loves driving or being in a muscle car, used to. Now you've got, then you went to your family sedans, so everybody piled in the car and went on the vacations. Now we've got the EVs, really cool, lots of cool new things. And now we're looking at autonomous vehicles are happening now and becoming more and more a real thing. So this all is a progression. Again, remember, cool new things. All those things that we're creating, that we're developing, that we now have, there's a level of complexity that grows and grows exponentially with each one of these changes that are made. When we think about vehicles now, the autonomous vehicles or the software-defined vehicles, we think about over-the-air updates, we think about digital twins, we think about all the things that have to happen, the ECUs that are everywhere, the millions of lines of code. Just give you a frame of reference. You may be familiar with this. Back in 1969, the Apollo 11 got us to the moon and back. About 145,000 lines of code or instructions. 145,000 lines of code to get us to the moon and back. Tons and tons of calculations involved in that. And the vehicles that most of us drove here today, if we rented them from a rental place, probably has 100 million lines of code or more. That's a huge level of complexity. Think about all the sensors involved. It used to be I'd go out and kick the tires on my truck, right? And that's how I figured out if the tires needed more air. Don't need to do that anymore. There's a sensor that says the air in your tires is low. Okay, cool. Again, lots and lots of capabilities, lots and lots of code that tells the cars what's going on and what tells you what's going on. But again, much more complexity. And with that complexity comes a whole new level of engineering. We think about the requirements management, the ability to trace those requirements, to comply with regulations, the ability to simulate what the vehicle's doing, model it, see what it's supposed to do before it ever gets to production. Understanding all of that, understanding how the software links together and works together and does what it's supposed to do and tells you what it's supposed to tell you, makes the emissions work, fuel mixtures correct. All of that is code, all that's software, and all of that has to be managed, traceable, reportable. That's all it's all a much higher level of complexity, not just from the standpoint of engineering the vehicle. Think about the security itself. Every new capability that we plug into all our new stuff, this isn't just automotive manufacturing, this is everything, but every new capability creates a new attack surface for security. So when we think about these cool new things and these new capabilities and upgrading over the air and connecting through the internet and data chips on the cars to do things, we also have to think of how is it being secured? How is the supply chain? Where is it coming from? What's going into the code? Is it being monitored? Is it being protected? Is the right person or the right people accessing what they need to access? All of that's extremely important. So we think about, once it gets out of engineering or out of design onto the production floor, that's a whole lot different too. And think about, the days of old when the manufacturing, the production line it was each person had their own personal reputation on the line for everything they put together. The guy before him put something on it, they put something on it. It was all, they watched it as it went by. They made sure that there were no dings, no problems, no issues. And the car typically made it out to production in really good shape. Things are a little different these days. We don't have a bunch of guys on a production line. We have robotic arms. We have hundreds or thousands of vehicles being created simultaneously. We have automatic spot welds, and we have different pieces and parts going together. That's a huge level of complexity. You're not going to have a guy running through there making sure all of those welds go together, right? It's just not going to happen. It can happen in some different fields, but in so many fields, you just can't do it with the human eye. And that's really where you also have to go in and apply the available technology. MVI, Maximo Visual Inspector, is one of them, that can actually go in key areas and monitor what's happening, when it's happening. Is it going together properly? Are the welds in the right places? Are all the pieces and parts in the right places? That's what our modern level of production has to be now for us to be able to get it to market without having an error. Because remember, the cheapest defect is the one that never leaves the factory. And that's what we're shooting for, is make sure it doesn't get off the line out to somebody and have to be recalled, because then you got a whole new level of risk and cost involved. So we think about the AI and how that's going to play into the environment now. AI is going to accelerate development. It's going to accelerate analysis and simulation, testing. All of those different things, they're not going to decrease in complexity. All those capabilities increase complexity. AI is helping us to manage it and keep track of it and do new things, but it's no less complex. The future, we think about, we've gone from mechanical to digital to software defined to AI assisted. These are things that we've seen. What are we going to see next? What's coming in the future? It's hard to tell, but we know that quantum computing is on the horizon. We know that we've heard of fusion for energy. Is our fuel source going to remain batteries? Is it going to remain gasoline? Or is it going to go to something else? We know we've been looking at hydrogen for a long time. Is that going to become a bigger play? Are we going to look at whole new things that we haven't even thought of yet? Is quantum and AI going to introduce us to concepts or allow us to get into things that we haven't thought of yet? It's all going to come in the future, but the single thing is, the challenge isn't going to be, are we going to be able to make smart vehicles? Are we going to be able to make smarter vehicles? It's going to be, can we continuously understand, govern, secure, and evolve the increasingly complex infrastructures that are involved in creating these really cool things that we enjoy creating as humans. We love new things. We get tired of old things quick. So are we going to be able to keep track of it? And that's what organizations that are going to be successful are going to be able to do, is incorporate whatever new technology we have available to us to help us manage the complexity that we're seeing grow exponentially almost from day to day. Think of it in terms of engineering, security, operational intelligence, manufacturing excellence, quality control. IBM has been around for a long time, That's what we've always helped our partners and our customers manage. IBM is here and will remain here and looking forward to the future and helping all of us, all of you, navigate all of these complexities. Thank you so much. We hope you guys will stop by our booth in a little while. I think we're number 3 in that huge vendor room over there. And we'd love to talk to you about any of this stuff and get into any of the details that you're interested in. Again, thank you guys so much.